Hello again, Mr. Internet, and welcome to John Boy's Radio and Electronics Workbench. What do we have today? We have a Huntron Tracker 2000 by popular demand. Somebody asked me to review this and show people what it does and how it works. Some people are not going to want to spend the money on these. They're very expensive. This one, the history of it is I've had it since the 90s. They quit making this model around 2000, I think, and then they went to the 2800, which is an LCD, not a CRT readout. And then they went to the 3200, I think, right now, which is the latest and greatest, and they're up there around 10 grand. And if you wanted a 3200, they sell for about 5 grand. And this one here, if you can find it, $800 to $1,200 is kind of the ballpark where you're going to see this one go for money. So let's jump right in. First of all, I'd like to show you what the instrument puts into its test leads. So we have a set of test leads here that go up to the Huntron there on the upper left. And we're going to show you what happens when you push the button or short the leads. So when it's normally just sitting there, the Huntron Tracker shows a horizontal display of a line. It's sweeping back and forth. There's an AC signal coming out of these probes, and when you short the leads, it goes to a short. So that's an open, and that's a short. Now let me show you on the scope what it actually is putting out. So if I clip this on here like so, and clip this on here like so, if I can keep it on there, there we go. I think, nope, great leads there. Okay, what you can see there is you have a alternating current, it's a sine wave coming out of the test leads. And it's plus or minus 10 volts, so that's a 20 volt span. So when you look at the Huntron Tracker up here, you see that it's sweeping, the middle point is 0, 10 volts here, 10 volts here. And when you short the leads, it goes to current. And current reads in a vertical manner. Now, first of all, I'm going to show you what it does at different ranges. So this thing will output 60 hertz. It'll put out 400 hertz, and it'll put out, let's see, what is that? 2000? I'm going to see my eyeballs don't work anymore. Yeah, 2000 cycles. Go back to there. And then as you go up through the ranges, go to medium, it goes to 15 volts. Peak to peak. Well, that's 30 volts peak to peak, or 15 volts peak. The other one was 20 volts peak to peak. And then when you go up to the medium, it goes up again. That's about close to, that'd be 30 plus 10, so 40 volts peak to peak. And then when you go to the highest range, it goes way up there to 120 volts peak to peak. Now you think, wow, that's going to blow stuff up. That's the magic of this unit. It doesn't blow anything up. The crazy part of it is that, okay, I'm showing you what that is. I just wanted you to see that. Highest range, highest current, 400, 200. Let's go back to the low range, because that's where I use it mostly. Take that off of there. I'm going to bring over the current meter and show you what kind of current it puts out. I can't really show you what the AC signal does, but I can show you half of it. Let's see if I can get this in here where you can see it. Getting this hooked up might be fiddle fiddly. Okay, about like that. So we got our leads here, and I've got this set up on the 100 milliamp range on the DC because it won't. This thing doesn't do AC current that I know of. I tried to do it, it didn't work, so I figured if I just put a diode across it would be good enough for showing you the interesting part of current that it puts out. So if you put it like this is a 1N 4148, it's just a pin diode, so I can show you what it does when you hook a, I just want you to see how much current it does. So there you go. This is on the 100 milliamp range, 100 milliamps full scale. So right now it's putting 50 milliamps through this diode. That might be considered a lot, but it won't hurt it. It won't hurt it. And the voltage drops to pretty much nothing except for when it's in its thing. So you'll see because it only conducts in one direction, you see a line where it's open and a short when it's on its other leg, and that's what you're seeing. That's what a diode looks like, and this is what the current is. Now, if I up the low to medium, look at how the current drops off. The voltage goes up, but the current goes down, and as I go up in range, it draws less and less current. And that's just a interesting way that they work to keep you from blowing stuff up at high voltages when you're trying to get in there and look at something with the high range, which I hardly ever use that highest range. I mostly use mine in the low range. Low range 60 cycles will do pretty much most of the stuff that you want to do. So that's kind of what I wanted you to see there. Let's get this guy out of here and start with the other stuff. Okay, so I can keep this from falling on the floor. Okay, that's out of the way. So now let's look at some components. First of all, I've already showed you what a diode looks like, but we'll show you again without the meter in line. Shows you, okay, this is what a diode looks like. And my meters are kind of oxidized. This is kind of oxidized. It's going to be a hard time getting it. It's been sitting around for a while. Get this on there right. Okay, that's a nice looking L. Okay, so if you can imagine in your head, that's a short. It's AC going into the unit. That's a short. Okay, half of it's conducting and half of it's not. So you put an AC to it, and that's what you get. And this is where you go, the aha moment. The aha moment. And then I have a zener diode here. Now zener diodes they have the characteristics of turning on when they reach a certain voltage. And this will kind of show you that. If I can get these leads on here so I can show you. See, it looks kind of like a diode. Oh, I didn't show you. If you change the polarity, it flips it the other way. Change the polarity, flips it this way. So a zener diode looks the same until you start going up. I'm going to put this on auto so you can see what it looks like throughout the range. See, it gets to the higher voltage, it starts to trigger the diode, and there's a spot where it's open and there's a spot when it's shorted on one half of the cycle, and then on the other half of the cycle, when it gets to a certain voltage, it triggers the zener and shows it a short there as well. Okay, that's pretty cool, huh? Now resistors, I didn't bother getting a resistor out. I should probably do that. I'll probably just do it with this circuit board here. Resistors just read a slant. So if I can find a resistor that's going to be reasonable here, get on this board here somewhere. Oh yeah, that's showing all kinds of fun stuff there. Let's go to low. Let's see if I can find a low resistor here. How about this guy? Hard to find a resistor. I might have to get up and go get one here. There's a resistor there. There, okay, there's a 120 ohm resistor. 120 ohms. And it's not a short and it's not an open, so it reads on a slant. So there's that, and then as you go up, it applies more and more voltage, less and less current, and looks more like a short. You can't really check resistors with it, but you can certainly see if they're open or there. I don't use it for resistors myself, but that's kind of what a resistor looks like. I'll show you what a diode looks like. Now, transistors, as you know, most of you do, they are two diodes back to back. So let's get on this guy. This interesting. This is a 2N3904. It's pretty simple. So there's a diode there. There's emitter to collector, which shows an anomaly there. I think that's a capacitive anomaly. I'm not sure. A lot of the transistors you measure, emitter collector, they have that little boop on there, and I'm not sure what it comes from. It has something to do with the junction. And then from here to here, you have the other junction. So here we go. Let's this is the emitter to base, and emitter to collector. So that's kind of how that works. And if it's shorted, it'll just show a short. Let me put it on auto here and show you what it looks like through its range. See, it doesn't really change much when you're doing that. And then from this, it shows you even more. It even shows you the capacitance, the internal capacitance of it, and it's a little bit of leakage. This is still a good brand new transistor. It's one junction. Oh, I get my hand out of the way here. Get my symbol out of the way. Oop. Get my hand out of the way so you can see what's going on. It's kind of hard to see, so there you go. And it almost acts like a zener because it's triggering the transistor to turn on a little bit. Now, I don't know why different transistors read the way they do. I've gotten used to using the instrument, so I know what good transistors look like, and I know what bad transistors look like. I don't have a bad one to show you, but they usually end up looking like a resistor because they're partially shorted. So I like to get into the capacitor part of it. The capacitors are pretty interesting. I have some good capacitors and some bad capacitors. I pulled this circuit board out of my junk bin, and it's an old brown board 148 GTL that's got all of those gray caps that are 45 years old and have long since died. So let's start with low, and start with is a 10 microfarad cap here. This is the 10. I got a 10 here and a 47 there. So here's the good one and the bad one. Sorry, I had my hand in the way for some of those measurements, but I'm sure you'll get the gist here. So this is what a capacitor looks like. This is a 10 microfarad on low. Nice. This is what you want to see on a cap. You want it to see it charging and discharging in both directions. Very nice and smooth. Put it on auto, and you can see the capacitive reactance is reflected in the fact that the capacitor looks like a short when you get up to the higher ranges, because you're higher voltage and it's charging faster. Okay, so another thing is if you look at the capacitor on this range, and I change it to 400 cycles is a higher frequency, so it's going to show closer to a short. So it charges and discharges faster. Now the capacitive reactance is lower, so it looks more like an O. So if I go even higher to 2000, it's getting even closer to looking like a short. Now most of the time you can only do about 1,000 microfarads with these. Anything above that and it's just going to look like a short. That's a 10 microfarad. Now I'm going to show you what a bad one looks like. This is one I pulled off the board. This is the same value, 10 microfarads. This is what I look like. I usually look at them when I spot check these boards. I'll pull a couple out and just bang them on the tracker. See that crazy that look like? That's the bad one. See how it's an O, but it's a slanted O. Let's go back down here to 60 cycles. Slanted. 400. Slanted. Here's the good one again. The value is not there anymore and it's leaking. Isn't that nice and round? This one is not nice and round. It is definitely a bad cap. You notice that the slant, it's got characteristics of a resistor and a capacitor, so this is definitely leaking. And the tracker tends to show that very well, and it will also show up in an ESR check. If you tested the ESR, its ESR would be quite high. Now here's a much higher. This is a 47 capacitor. I'll show you a good one first. And of course the O is going to be bigger because it's a larger value. There's the O on the low range. And as you go up, as it cycles through its ranges, it looks like a short pretty quick because it's a larger value. Okay, now I'll show you the bad one. This is a bad one. This is what I see when I see bad ones. Oh, look at that. That's nasty. It's got a crooked and curly cued. It don't like to discharge or discharge very well. Put it on there. You can see it still has capacitance, but it's leaking and it's not good. Whenever I see that characteristic where it looks like it's slanted, or when you first hit it with the leads, it starts and it goes like that in a kind of a dance. So let's go to the higher frequencies here. 400. Even shows more of the slant there. Where the good one is a nice, almost straight up and down, no slant to it at all. And that's what you want to see on a new cap on this instrument, is it opens up. It opens up from a line and opens up like this linearly on each side. And if it doesn't do that, cap is no good, not a gotta. So at 2,000 cycles, it almost shows a short, but that's a good one. And on the bad one, again, it shows a slant, which just means this baby is leaking like crazy. Leaky. And that's a lot of the problems that we have with these boards. Now, another thing that the tracker does fairly well on older units. Now, you can't use this on laptops or any of the CMOS stuff that's around today because the voltages are too high. And that's what they've improved with the 2800 and the 3200. They give you way more ranges. So that instead of a minimum voltage of 10 volts or 20 volts peak to peak, you can dial it down to less than a tenth. I think it's 2 volts or even a half a volt, probably a half a volt or less. So the sine wave coming out is less than a half a volt, so that you can look at the capacitors and not trigger any of the diodes that usually conduct at about a half a volt, and transistors, which usually start to conduct about a half a volt. So for old through hole, this is a really good. If you're doing this kind of stuff, it's kind of a really nice instrument, and I've used it many times for troubleshooting shorts. You get in there and you go, I think this cap might be shorted, and you don't want to pull it. You just want to spot it real quick, and you come in here and you put your leads on it. It will show you if it's shorted or not. I don't think I have any shorts on this board. Okay, I'll show you. What I'm going to show you is this big cap here. This big cap here, I think it's still good because it's a big one. It's 1,000 microfarads, and it shows a short there, Down here it's really close to being showing a short, but that's 1,000 microfarads. You get up there around 10,000, you can't. There's no way you can just differentiate it between a short and a capacitor, because the value is too much for this instrument to detect. So that's what that guy does. Now I'm going to show you, if you're looking, see that I got a diode sitting down here. I'm going to check around it, but unfortunately it has a cap around it, so it's going to show the cap and not the diode. So you have to pull this guy out of the circuit to see it. Here's another diode in circuit. It shows you the diode and the capacitors around it. So there's capacitance in there and there's the diode, but it would show you if there was a short. Now here over here on this, if you've ever seen the AMC circuit on a 148 in this area here, I know the shadows are kind of crappy, but right in here we have two transistors that are hooked in kind of a Darlington, or I think it's not a Darlington, but they're direct coupled. So when you check this, you're going to see a junction everywhere. You're going to see junctions everywhere. There's that one. Okay, that's got a resistance, so there's some resistance in there. I'm not sure what that comes from. I don't think that's the device. You'd have to pull it out to make sure, and that's one of those things. I've never seen one leak like that, so I'm going to say that's good. But you get over here to this other transistor. If I can get on it, there we go. This transistor's in circuit, and it shows you what's going on. You go to, it's all the leads, and you see that there's a junction everywhere. And the reason that is because it's directly coupled to this one, so it's seeing junctions, all the junctions that are connected simultaneous. And you can do capacitors in line. You can look at some of these caps that are kind of on here. You can look at a couple of them here. I can't close you up, give you a closer view. But this instrument it's very useful. I mean, I've used mine for years. The first one I used was a homemade job that somebody made in the military, that they made it and it used an oscilloscope for the readout. And it works pretty good. It's pretty simple to make too. So here's a capacitor. I think this is the same one we were on before. You see there, yeah, that's a suspect right there, that cap. See how it kind of started a certain way and then it kind of started moving as it charged? These caps have, yeah, that cap's got a problem too. I'm sure all the caps on this board are either dead or dying. But you can go to any one of the transistors in here and you can see whether they are shorted or not. It may show you anomalies like I was saying before. So here's a junction, there's a junction, and there's a junction. There's all kinds of happy stuff that happens when you got capacitors and diodes and everything all in the one spot there. You see an interesting array of stuff. Now, if let's say you had two circuit boards and you wanted to compare between them, you can do that too. You can make a common point. You can add another lead right here, and you can push this button and it will go back and forth between the two and show you the difference between the two boards in that one spot from a common point. It might not be ground, it might be just where you wanted to measure, and you could measure that or watch what happens. So that's really all I have here. I mean, it's a simple unit, but it's got a kind of a steep learning curve for those who have never used one. You'd have to sit down and play with it for quite a while before you really got the gist of what's going on here, because a lot of people think it's just out of their range, and it's not. These units were very, very well sought after back in the day. Now there's other things that are even, probably even more better. We have all of these digital VTVMs, and they have they have continuity beepers, and you don't have to actually look at anything. You just measure, and it'll beep if it's a short. or it'll show you the voltage drop across the device on diode, and that's all the new stuff. This is kind of an older school way of looking at things, and it's what I used to use all the time. Because back in the 80s we didn't have anything like we have today. So I think that's about as far as I'm going to go with this. I think I gave you the gist of it. I can't think of anything else to add. It will check SCRs too. There's a pulse generator section over here. I never use it, but you can put pulses in, negative and positive pulses, and you can change the width and have a pulse generator, and then you can apply voltage to a SCR and watch it trigger. And then you can see if the SCR is turning on and off or not. I think that's what this is mostly used for. I never used it myself, but that's supposed to be what it does. I think you can even check relays by doing that. You can make relays go on and off with it with a pulse, so you can see if the relay is doing what it's supposed to do. But that's really all I have. Okay, I guess we're done with this one, and I don't know if you made it to the end of this one, like I said on the last one, but if you did, thank you for watching. Please like and subscribe. God bless. And we're getting close to the new year here. I should say Happy New Year coming up, and Merry Christmas if I missed it. So we'll see you in the next one. Thank you for watching.